Yeah, we welcome you all, our lovely viewers, to our podcast. As usual, still my guest is Ingva. Yeah, and today our topic of today is going to be about curiosity. How do we create curiosity into students through interdisciplinary learning? Yeah, so
Mm,
I'll give this opportunity to my guest to say something.
thank you, Samuel. Okay, this is very interesting topic, and today it will be very practical as well. Okay, so we are talking about investigative learning. Investigative learning is crucial, actually. Okay, so we forget it. Okay, so usually in the classrooms we don't investigate anything. Okay, so we listen teachers and we discuss. Okay, so perhaps some issues or tasks or topics, but investigative learning is basic for learning in general. Okay, so if you take small babies, they doing research. They investigate around surroundings. They test the different objects and so on. Okay, it's called investigative. Investigative is not only for science. Investigative approach is for any subject. It can be history, it can be literature, it can be reading of the books. Okay, so because the content you investigated, and this is a key actually to get curiosity back in our students. Okay? If you create a learning environment with different activities and different tools, okay, new ones for our students. In this case, you succeed, okay, as a teacher, and you don't need to, okay, so think a lot, okay, so how to proceed. Uh, Today we have, okay, so some interesting, um, yeah, investigative tasks, and yeah, it's sunny day. Okay, so no clouds is coming. Okay, so but it's good as well. Okay, so because we can measure everything. Okay, so not everything, but what is important for this subject.
So
Uh,
today we are going to include technology
yeah,
into investigative learning.
yeah, absolutely correct. Okay, so we are connecting the modern technology, wireless sensors, and we take interdisciplinary, short interdisciplinary topics and tasks. Okay, so to do research. Okay, so yeah,
Yeah, so these are the sensors.
yeah, those are the sensors, okay, so which make investigative task more interesting. Okay, so more interesting, not fun. Okay, so I don't like word fun. Okay, so because learning is it should be interesting. Okay, so, and such devices. Okay, so create uh, curiosity. Number one, okay, so what is this and how it works, and then okay, so you give activity for
I think
that.
most teachers need to adapt to the new technology that is coming up to involve it into the learning process of the students.
Yeah, I agree with you because after completed the studies and you start at the university, okay, so universities provide a modern technology in order to be able to build up something, okay, so to create something and so on. And if we don't introduce the idea of modern technology and give possibility with the simple things, okay, so to use them, in this case, okay, so we prepare our students not for today, we prepare our students for tomorrow. So it's a lot of things with AI, you know. Okay, so but we don't talk about that today. Okay, so this is wonderful topic for the next episode. But modern technology is it's very important. Well, because yes, of course. Okay, so students should be able to read, calculate, and draw and speak and so on. Okay, so know the like ground building blocks of the knowledge, but you need to show how to use them. Okay, so in new location. Okay, uh, I think I would like to introduce. Okay, so three sensors, wireless. They are wireless. You don't see any any wires here. Okay, so one is a ultraviolet sensor. The second one is humidity sensor. They are very interesting. Okay, so and carbon dioxide gas sensor. So and today we try uh, to uh, to involve them. Okay, so in the process of investigative learning.
What do you think makes these wireless sensors special?
Special, okay, so for teachers, okay, so it's data collection very quickly, and you can analyze the data from a different point of view. Okay, so you can use data for calculations, for proving of something, and so on. From another side, okay, so they are very easy to install. Okay, so if you have smartphone, we have an app for them, and it's very easy to connect. If you have our iPads or laptops, okay, with Bluetooth and such possibility, it means it's very easy to connect them. You don't need to have a lot of how to say, supply material for them. And from the students' point of view, okay, so they are simple, they are quite good to hold in hand. Okay, so, they are waterproof, they are breaking proof, and so on. Okay, so but I don't believe the students can okay so throw them. Well, because this is a device. For interesting investigations. Okay, so
That's interesting.
yeah,
Very,
they
very
are.
interesting.
Yeah, they are very okay. So I remember that 2003 I started with not wireless okay sensors. I started with in Finland with sensors in general. Okay, so it was quite interesting and giving to my students. Okay, so they were very well involved in investigations, and of course, okay, so my colleagues in Finland they as well. Okay, so started to use. Yeah, and now we have a second, third generation of sensors. It's yeah, from 2003. Okay, so it's 22 years. Okay, so went very quickly. So simple to use and reliable data about phenomena.
And I think today we are going to have the opportunity to show our viewers
Yeah, yeah,
on how
yeah.
they work.
Yeah, absolutely. Okay, so we show the hands-on activity. Okay, so if they want, okay, so to do this, okay, so yes, just call, send message to us, okay, so and they receive sensors you can order and they can continue with own investigation. And actually, if you give a topic. Like this very creative topic. Okay, so what can we do with the carbon dioxide sensor? So without preparation of anything, and ask students to mm, uh, plan or sketch. Okay, so make a draft for own investigation with this sensor. So in real world, okay, it will be very interesting. Yes, of course, they use AI for that. Okay, so but it's good because they connect. Okay, so with AI, okay, so have a proposal what to do with this.
Yeah.
So, but this is another topic. Okay, so we are all we are too modern. Okay, so persons here. Okay, so, but anyway, uh,
So we are going to do some experiments.
yeah. And today is, as I said, okay, so it's quite nice day. Okay, so it's sunny. and it's still summer, but the next week in Finland, okay, so the school starting, and but here it's in Belgium, we should wait a little bit, but I think uh, I think we start with ultraviolet, okay, so because uh, it's interesting topic. So, and now a little bit move, okay, so this one, okay, start. Yeah. This is a sensor, okay, so what we are going to use today, now, okay, so ultraviolet because it's summer and a lot of sun, okay, so around. Um, we open the application. So now we can, we moved from outside inside because it's a lot of light, and now it's better to show. This is ultraviolet sensor which is connected to the app in a smartphone. Okay, what we can do, we can uh, introduce. Okay, so the first activity for us in 1801. Johann Ritter wanted to know if energy beyond the violet end of the visible spectrum existed. Uh, he used photographic paper, and the photographic paper turns black more rapidly in a blue light than in red light. So he expected that paper, okay, so will be black as well. Uh, if we have something, okay, so beyond the violet end, the paper turned black, showing the existence of ultraviolet light. Okay, this is the history, and now, okay, so you will, uh, uh, of course, we all have heard about the dangers of ultraviolet on the skin, and the need of wear good protective sun cream or bright sunshine, and so on. In bright sunshine. In this, in this experiment, we can just, okay, so try to use uh, mm, plastic. Oh, plastic. This plastic. We need to start it. So live data. So this is. I think it's so. So and wait, graph. So start. So we can see, okay, so now I turn towards the window, okay, so it's little bit ultraviolet coming, okay, so if, so, now I put, window is open, okay, so now I put the shield, okay, so we see little, okay, so ultraviolet coming through. Through this, okay, so coming more. We can change the range of scale. Okay, so yeah, that's it's so little. Okay, so yeah. Now we are outside. Back. Okay, so and everything is connected. You see on a graph. Okay, so intensity. Okay, so yeah, ultraviolet intensity. It's changed. Okay, so because we have clouds now, and clouds now. So I will use this protective shield. Okay, so and you see that it's filtrating. Okay, so and here it's coming more filtrating. So filtrating, and now it's goes through the window. So you see, guys. So it's very impressive. Okay, so now I prepared it's like a window here to put, okay, so different materials. Okay, so if we have a t-shirt, okay, so a white material, cotton. Now we can take a look. Okay, so how protective it is. You see. So yeah, white is quite good to protect body. Okay, from the ultraviolet. Okay, so now let's see this one. So 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 first we take a look. Okay, so ultraviolet outside. So and then we go here, and so it's totally protective. So then we can take a plastic. So it's both sides. Okay, so here it's a red or white one. Okay, so let's start with white side of plastic material. So this is actual intensity of ultraviolet, and then we put here plastic totally okay, separate damping. Okay, so the ultraviolet. And now we take a little bit another side of it. Okay, so here we have a real situation.
So when you put it there to direct sunlight, it goes high.
Yeah, very high. Okay, intensity high. Right now it's good. It's now right now it's quite good because we have clouds here.
But when you block the sensor with something like material, like cloth, it reduces.
It's reduced. Okay, so this is like this. Then this screen, okay, so actually as well, okay, so absorb ultraviolet little bit. You see,
that's a transparent material.
Yeah, transparent a little bit. Okay, so will reduce, but let's put some sun cream. So sun cream. Okay, so we put it here a little bit more. So sun cream, and then so sun cream, and then we put. Okay, we compare through, and now here. So it's not so good sunscreen.
It goes a bit.
Yeah, a bit. Okay, so but it's not protective as, for example, t-shirt, white t-shirt. Okay, so then we can take deo. Okay, so as well. Okay, so is it protective or not? Okay, so once again, we take a measurement through the screen. Okay, so we have a point there.
Yeah.
So, and now we put deodorant. No. So, we take a look now. So, yeah. So, it's functioning as cream with a similar level of transparency. Even less it goes down. Okay, so the other answer would. Okay, so in this case, so to protect. What can we do with this data? What can we do? This data we can analyze now, okay, and compare different materials. Okay, so how good they are to protect us from the ultraviolet. Well, because nowadays, okay, so with the climate change, it's a lot of sunny days and very hot and very intensive, well, ultraviolet radiation. So, okay, this was the first, okay, so quite interesting activity. I think it's very interesting because students can, okay, so create own pathways. Okay, so this is general, but they can test what they want. They can go under the tree, for example, leaves, and to see, okay, how protective they are against ultraviolet. Okay, so we take a look another sensor. It's called the carbon dioxide sensor. It's as well quite interesting. Okay, so device sensor itself collecting. Okay, so carbon dioxide is here, and so the transmission. Okay, so it goes to the smartphone. Okay, so smartphone. So and here we see connected. So now we're connecting, and
So these sensors connect through Bluetooth.
yeah, absolutely. Okay, so now we have a connection here. Okay, so now it's connected. So carbon dioxide, and now we can start collecting all the data. So we can put in a graph. Okay, so. Now it's approximately 210, 220, 250 ppm units, and it's very easy to show. So my breathing, okay, so made. I forgot knife. Okay, so but anyway, so 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 now we have carbon dioxide sensor inside, and it shows, okay, so that nothing happened. Okay, so what happened if we expand on a sun? So yeah, actually nothing happened. Okay, so yet, but perhaps something we need to do, and I think it's quite good to have perhaps a little bit water here. So so let's see what happened now. Okay. Very interesting.
It's very interesting.
Yeah, and now, okay, so this is a question to all students. Okay, so what happened? Okay, so can we explain this phenomenon? What happened? Okay. Now I opened the box. Okay, so now carbon dioxide, which was produced there. Okay, we are quite sure that carbon dioxide amount, okay, so goes down, decrease. Okay, so but if we know photosynthesis chemical reaction, uh, we understand that uh, it will be in the beginning, okay, a lot of carbon dioxide from surrounding, and it's consuming, and after that, okay, so it's produced uh, sugar, okay, carbohydrate and oxygen, a lot of oxygen. So this is very interesting. Okay, so it's phenomena. Uh, yes, of course. Okay, so we can continue with the carbon dioxide. Uh, it's uh, it's very interesting to compare the open environments. There is a much concern at present about the impact of carbon dioxide in the atmosphere and how it will affect the climate. Carbon dioxide is, as we know, it's colorless gas that is denser than air. It is present in the atmosphere as a result of respiration from all living things. And what we want to do today, we compare. Okay, so carbon dioxide in different areas of uh, environment. For example, right now we are outside and it's quite good. Okay, so level of carbon dioxide, but if we go, okay, so for example, if we go a little bit outside, okay, so for example, to yes, okay, so it's reduced, but more interesting if we take and go on a road with the cars. And in this case, okay, so we can see increasing of carbon dioxide. Well, because we still use okay, so cars on fuel. In breathing, so it's effect of my breathing and talking, guys, and can imagine, okay, so that if we are 20 students in the classroom with a bad ventilation, it will be very dangerous. Okay, so not good for health. Okay, uh, you can use carbon dioxide in order to um, do research about baking with the yeast and well, we want to bake today, but I think we have uh, quite limited time now. Okay, so uh, but next time we will show our result, baking result, and measurement. Yeah, the next one we can. Okay, so this data we can transfer. Okay, so and everything can be done very easy. Okay, so set up, but we don't set up, we disconnected. So, and
So it saves and
yeah, and
all the data.
yeah, all the data, and then you can, okay, so use it, okay, so later for analysis. So
that means there's an advantage of also good data collection.
yeah, this is and
Data is
reliable.
saved into your
Yeah,
device.
and this is what is important in science, okay, so because you need to have a database solution, okay, so make a conclusion on a data. So
So our next experiment is going to be about
transpiration and humidity. Okay, so we are going to use uh, humidity sensor. So and oh, it's windy. So humidity sensor. And yeah,
I'll show our viewers
Yeah.
how it looks like. So this is the humidity smart wireless.
So it's on. So, so. It's always goes a little bit. Must close it. So there. So now it's connecting. So and nice. Okay, so now we take first measurements. Okay, so we can see the percentage. Okay, so time reading. I think humidity is quite high today, over 60%. No, it's so we connected now humidity sensor to the app, and humidity is 30.44%. Okay. So what can we do? We can, for example, investigate the transpiration of leaves. Okay. So we need two cups here. So we need paper. I need water, of course. Okay, so just a moment. So and now we cover it. Okay, and we need to wait a little bit. Okay, so then we can measure humidity increasing. Okay, so you see immediately a little bit goes up, and here it's a reading. Okay, so here it's readings. So this evaporation. So you see very simple experiment, but a lot of data to discuss and to prove that leaves are breathing. So it's everything good. So okay, that was a simple experiments with wireless sensor. Thank you.